Okay, guys, I'm going to go ahead and do number 17 here. Now, this isn't ideal because there's only one example of this. And so you can't really take my video and go practice, but that's okay. So if you need help, watch the video. If you think you can do some of it on your own, maybe stop the video, try some of it on your own first, and then you can come back and watch if you get stuck. So I look at, and they give me a function, right? So they give me a function, f of x equals 5 times 2 to the x. And they want me to fill in the table, fill in a graph, and do the domain and range. So let's just get started with the easiest part. Let's fill in this table. So I've got 5 times 2 to the x. Well, I know that my starting point is 5, okay? Because that's where I always put my starting point. It's the y-intercept. It's the value where x equals 0. So what's really important, don't put 5 right here in this box. That's a bad idea, okay? We want to put the starting point, the y-intercept, where x equals 0. So I'm looking for a 0 on my table, and that's what I'm going to match it up with. Okay, now, so I can follow the pattern now because I know that my common multiplier is 2, which means that for the pattern from left to right, all I'm going to do is I'm just going to multiply each one by 2. So 5 times 2 is 10. 10 times 2 is 20. Now to work back the opposite direction, to work this way, okay, instead of multiplying by 2, now I'm going to divide by 2. So 5 divided by 2 is 2.5. 2.5 divided by 2 is 1.25. Now you could have done that in your calculator, and that'd be fine. The other way that a lot of people really like to do this is just to take your function, okay? So take your 5 times 2 to the x, and you can plug any x value in to your calculator. So if you want to know the value right here, okay, where x equals 2, I can take 5 times 2 to the second power, and we'll see that 2 to the second power is 4, and 5 times 4 is 20. Or you could just punch it in your calculator, and we would get 20, would spit that out. So that's fine. You can do that for the whole table. Okay, so now we've got our table. Let's look over here at our graph, and we'll graph this real quickly. So I've got negative 2, 1.25. So negative 2, 1.25. I'm going to put a dot right about there. Okay, then I've got negative 1, 2.5. Okay, so I'm going to put a dot right about there. Good. Okay, 0, 5. So let's go 3, 5. 0, 5 is going to be right there. 110 and then 220. So 110. Oh man, and then this doesn't really make sense. Like 220 is going to be something like way up here. All right, and then I draw my line in. Now, what would have made more sense, guys, I'm not going to go back and do it. It would have made more sense to scale this thing differently so I didn't have to put a 20 way off the graph. But that's irrelevant at this point. So that's about what my graph should look like. Again, it's good because it's an exponential growth. So the line is obviously going uphill. It's getting bigger, which makes sense because our growth rate is 2, which is greater than 1. Now for domain, if I look at this, well, I know that my line is going to go forever in both the left and right direction. So my domain ends up being all real numbers. Okay. Now my range is the y value, remember. So if I look at my graph, I notice that down here at the tail end this way, my graph is going to get really close to y equals 0, but it's never quite going to get there. And what we end up with is this situation where my graph will never cross into this space below the x-axis. So I want to account for that in my range. So my range, I'm not just going to say all real numbers. I'm going to say all positive real numbers, which means all real numbers greater than 0. All positive real numbers. Okay, so that completes number 17.